All right, guys, here's question number 9. So I'm going to read you the question first, then we'll figure out how to set it up. So if I look at question number 9, it says how many grams of sodium hydroxide, NaOH, are required to react completely with 37 milliliters of a 0.5 molar H2SO4 solution in a double replacement reaction. So I'm given as a starting point NaOH plus H2SO4. Okay. So if I take those as my starting point, and I need to start by predicting my products. So I know I'm going to switch my cations here. In this case, that's sodium and hydrogen. So I'm going to have NaSO4 plus HOH, which is water, but it's easier if I write it as HOH because I can see where each part's coming from. So one trap you might fall into with this problem is thinking that because the problem is asking about your two reactants, you don't have to predict your products or balance the reaction. That's not the case because you'll still need that coefficient that might go in front of one of these in your mole ratio for stoichiometry. So you definitely have to still predict the products, go through this whole process, and then do your stoichiometry. So once I've predicted my products, I then need to make sure my oxidation numbers are balanced. So over here I had a +1, -1. Here I had a +1, -2 because I had 2 of them. So over here I've got a +1, -2 and a +1, -1. So I see that they're uneven here. I'm going to need 2 of the sodiums to balance out with the sulfate. So here's my Na2SO4. When I do that, I see that I've got Na2 here. Means I need a 2 out in front here. That also tells me that I've got 2 OHs, and I have 2 H's here, so I need a 2 out in front here. So here's where this balancing, predicting products is going to be important, because I'm going to need to use this 2. Had I not predicted my products and balanced the reaction, I wouldn't have known that that 2 existed there, and my stoichiometry would have been off. So now I can go back to the question and figure out what numbers I need and what it's asking me. So it's asking me how many grams of this I will need to react with 37 milliliters of 0.5 molar H2SO4. So if you can picture that in your head, I've got 37 milliliters of this. I need to know how much of this am I going to put in to react with it. Okay? So when I do my stoichiometry, I always start with the number that I'm given that is not a molarity. So in this case, that's 37 milliliters. So here I'm going to start my 37 milliliters. I'm going to set up my stoichiometry problem. I know that this molarity is in moles per liter. That means I'm going to need to get milliliters into liters if I'm going to be able to use that. So 1,000 milliliters is the same as 1 liter. So now I can cross out milliliters, and I've converted my units to liters. So now I'm ready to use this molarity here. I know that it's 0.5 moles of H2SO4 per 1 liter of solution. Notice that my liters match up here, so I can cancel those out. I'm left with moles on the top. So now my next step would be to go from moles of this to moles of this, because that's what the question's asking me. So I'm ready for my mole ratio. No number in front of here, so I assume that there's a 1. That tells me that for every 1 mole of H2SO4, I'm going to need 2 moles of NaOH. My last step then, I'm looking for grams of NaOH. Currently here I'm in moles. So I need to go from moles to grams. I'm going to use my molar mass. So I know that 1 mole of NaOH weighs 40 grams. Okay, so I cancel out moles here. I'm left with grams, which is what the problem is asking me. Okay, so now I multiply everything on the top, divide by anything that's on the bottom. I should get an answer of 1.48 grams of NaOH. There are two more problems like this. Problems 10 and 11 are both solution stoichiometry. So if you're feeling a little shaky, try those next two problems.